Okay, I put gain on my microphone because for some reason it's gotten quieter. Um, so this should fix audio issues. But anyway, I feel like I'm on a roll right now with this OCaml thing. It's like genuinely the most fun I've had programming in recent a while actually. So I want to continue it. I want to continue it. So far we've got well, I need to open it up because I just closed it. I this is me like 2 hours later since the last recording finished, and I want to continue. So I did have some ideas I wanted to implement, which are more constants, but that's easy. Functions, chaining commands, and then these operators are easy, and implicit multiplication. So I want to start with functions. I want to have functions in my calculator because like it ain't a useful calculator if it don't got functions. So first things first, let's actually add these Boolean operators because it'll be pretty easy and they're actually kind of important. I totally just forgot to add them. So back to our calculator. Whoops, not Vim, new Vim, and let's go. Where are we? Okay, we'll go to tokenizer and just add these here. So we need greater than. So greater than, which is this operator, less than, greater or equals, greater or equal, and lesser equal. Or rather just greater, equal, less equal. I could call it like left arrow, right arrow, but should I actually? Well, no, because an arrow has like a trailing thing. This is specifically, well, it's like left angular bracket, I guess. Should I just call it left angular bracket? Nah. Greater than or equal to is this. Right, so the font does actually pick it up. And less than or equal to. Yeah, JetBrains is quite W, quite W. This, oh my God. Okay, cool. Spacing be damned. So, yep, just to go ahead and add these. I need this to match first, so I actually need to add to them below in this case, for the less than sign. Because if there's an arrow, then that should pick up first. So otherwise, token map, token dot operator, less than. Yep. Then I'll just put the rest here. So we got greater than. We've got greater than, less than, or equal to. Should we change the order actually? 'Cause just yeah. So we need to add this. Okay. That's less equals, I think I called it. Yep. And then greater than or equals to. Greater equals. Okay. So that's done. Now to our, whoops, whoops. Then to our parser. So we're going to need to add more operators. So we've got equals, greater than, less than, greater or equal, less or equal. Yep. And then these will have the same precedence as the equals operator. Yep. So let's find it. There it is. Just copy paste all these things. So operator greater than is greater than. Yep. Not too crazy. Boom. 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 There's 4 of these. Less than will be less than. Same name. Uh, greater equal. I think I called it. Yeah, greater equal. So that'd be greater or equal, and then less equal. Not the best names, but we will. Uh, less or equal. Okay, that's done. And then for the evaluator, like I said, very, very simple. Just gonna copy this. 1, 2, 3, 4. We got greater than, less than, less than, greater or equal. Going to space these out again, and then less or equal. Okay, and then just swap the signs, and that's it. So more than, less than, greater or equal, and less than or equal. Then for these, just we'll go virtual block mode. Yep, and same here. Cool. So now we need to also make sure the tests line up here, or that we have tests in the first place for it. So you got not equals this, okay. You want eval test, okay. 5 is more than, yeah, 5 is more than 3. Sorry, I was thinking of something else that might be an error, but I think it's okay. Just because, like, hopefully the greater than equal sign, the greater than sign doesn't conflict with the arrow, because like the no, the less than equal sign, because the left arrow is a parsing error if you use it inside an expression. But I don't think that should break this. So 5 is greater than 3, 3 greater than 5 is false, and I guess it's like a bonus check. 5 greater than 5 is also false. There are 3 cases really to consider. And the same thing for less than. So for less than, it's 0, 1, 0. I could be like organized with these tests better, but whatever, man. And then here for greater than or equals to, I'll actually copy this. Here. Yep. Only difference is that this is now true. And whoops. And this is also now true. Okay. That's it. So now if I duplicate my window so I can get this here, zoom in for you guys, June test. Okay, what's wrong? This greater equals, did I mean that? I didn't mean that, yes, thank you. What line is this on? Tokenizer. Okay, so tokenizer. Here. Let's go N actually. Yep, equal, equal, less equal, greater equal. Really great names here. Parser, greater equal, less equal. Okay, that works. Well, that is correct, I should say. Let's see. Less equal, this main question was high professor. Okay, apparently I messed up the names. Let's go to our tokenizer. These do not match up. Speaking of matching up, let me just make these uniform. Okay. These are not equally spaced. So I think I'll just add a space here. Not that it matters, but yeah. It does not look great, but should I prefer on this side then? Oh, 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 okay. Yeah, for some reason that just looks better, even though it's same spacing. Um, redundant case, this case is unmatched. Redundant case is unmatched, of course. Whoopsie daisy. Thanks for warning me. Don't we just love compiler warnings? Because now it tells me to just do this, and that should work. If the test passes, and the thing passes, so again, git adds, git commit, adds ordering operators. Okay, so I can now scratch this off my list. Now, that was easy. I want to add... Should I add training commands first? How do I even do this? I need to, in the tokenizing stage... No, even before that, I need to like split it into different expressions by the... So yeah, do I even tokenize this? Like, I can tokenize the semicolon. And then I just wonder how I'll treat that then. Because they're like their own expressions that aren't related to each other. Um, yeah, so I can either do for training commands, which if you don't know what I'm talking about, I'm talking about this, like x, like store 5 and x, store 3 and y, and then output x plus y. Like you can see, I'm chaining these together. So I can either treat these as separate statements from the calculator side before tokenizing even happens, or I can tokenize it and then somehow use that to split up the binary tree. But the parser only produces one tree. Because like I prefer if the parser was just used for expressions and then like everything else was not. Um but surely like when people write programs, they also tokenize. Hold on my parser. That's right. But I have like a special thing between my parser, don't I? So in my calculator ML, if you look here, we can see I tokenize and then I do this. Whoops. I I can't remember how to type. I do this. So I check if we're signing to anything, and if we are, then I keep that. So that's like another step I've inserted. Um, and I could do the same here, just like run the parser that many times by splitting on semicolons. Yeah, I guess that makes sense. So I'm thinking, should I add another intermediate step between the tokenizer and the parser called the, I don't know, the parser handler or something like that. I don't know. First of all, how do I split by semicolons? Like in OCaml, is there like a built-in function for that? Because I could, I can just take while token is not semicolon, and then just keep doing that until the end of the input. Right? But how is there a built-in split function for splitting a list by some delimiter? A list, not a string. Yeah, let's take while. Yeah, fair enough. But then how do I check if I'm at the end as well? Like, empty list is the end, right? Okay, then yeah, I can easily do that. So let split by, or split by is fine, where we take a delimiter. So I mean, I'll call split token by, but I was just thinking I could make this generic, I guess. Although, yeah, how do I do that, actually? I mean, this is generic, isn't it? But like, how do I make a generic? Or how do I name? Oh, I know how. I know how. So split by. Yeah, let's make it generic just for learning purposes. So I'll take a delimiter, which will be I think this, and then list. But then I need to have this as well. I think. Let me just verify. How do I do generics in OCaml? Because yeah, if you do generics are called type parameters. Yep. Okay, that's for types. Okay, thought so. So just not here. That's for types only. So it's this, and it returns. Oh, and we just need to take a delimiter. So it'd be a, then the list. But I can't call it that, so I'll call it like list. And then return a list of lists, right? So a list of lists. Okay, we're going to do I make it, no, I don't make it recursive. So I define a function that is recursive called go. Do I need to do that? Maybe I can make this recursive actually, because because I need to keep track of my output. No, but it's fine because I can just let me cook. Okay, so I think I can do take while list dot take while. Uh, call it x, I guess. Sorry, function x. Sorry, element x. Take while x does not equal delimiter. List. And then call itself again, right? So we'll do not a function. I could do function for now. Let's make it explicit. So match list by with even. So if it's something, just do list prime for now. If it's list prime, then do that. If it's empty, then just return this. Yeah, so it'll be list take while, cons onto list dot drop while, same function, and we're returning that in split by. Yeah, I think that's correct. And let me just use it. So how do I iterate over a list? I did it in my what do you call it? Constants. Let's not iter. Yeah. Yep. So list.iter function x, or like function tree, or tokens, I guess. I mean, I have to shadow it then. We'll do like token. pool. Okay, so we have a token pool of tokens, and we want to for each one we need to do this entire thing. We're both getting the AST and evaluating it, I believe. And the final result is what we show. Show. Let's let final result equal a ref float in is how I do it. Let's check the variables because I think I use it here as well. No. Where do I use this? I use it in calculator itself, don't I? I use it here. Yep. Okay, so that's just ref. So yeah, so ref should be fine, but it's not ref float. It's ref 0 point, I guess, of which is a ref float, or even a float ref, maybe. Okay, and then I just take this. Return final results. Okay, wrap this and apply it to our list, which is split by tokenizer.token dot let's do like plus for now. Tokens. Right. And here as well, final results, assign it like this. I mean, I'm not very confident that it's going to compile, but I think the logic, I think my thought process is in the right direction. So instead of tokens, this needs to be token pool. I really need to just split up this function, but whatever. Okay, let's try this. Let's try this out and see what happens. Yeah, it looks okay. So let's just test. Syntax error on line 7. And that's correct. Be like this. I mean, my split by logic is probably wrong, but the expression is type a list. An expression was expected of type just a. The type variable a occurs inside a list. Oh yeah. What's x? We're applying this to list. This is a list of lists. Yep. We need the concatenation thing. This concatenation. Can't remember what that is though. It's at. Okay, it is at. I thought so. So it's should be this symbol. The type variable A increases inside A list. What about it? Split by. Split by. Whoops. What? That's correct. This needs to be have an argument. Where's the delimiter? Just delim. Pass it through. I guess that's why I'd use like a go, so that I don't have to pass through the delimiter each time. But this expression is type list. Expected list is list. What? Uh, which expression? This one. Well, yeah, I'm returning a list of lists, not a list of lists. List or take while function of this is this. Yeah. Uh, God, this would be so much easier to do imperatively though. Um, no, this should be this, and then this should be this. But I don't need to do that because it will eventually finish on this. Yeah. Like here, I have a list. I cons it onto another list. So then, do I need to like cons it onto like a list like this? Maybe just an empty list of lists. A list of empty list. This case is unused. Okay, that did work. But yeah, this obviously isn't matched. This should be this. This case is still redundant. Why is it redundant? Because this needs to come first. Okay, line 47. I have to do reference. No, I don't. I don't have to do reference. I do have to do reference this though. The expression is type unit, but an expression was expected of type a string result. Why is that? Why is that? This doesn't. So, oh wait, I mean, this wasn't part of it anyway. Ah, that's annoying. The function needs to match, I guess, like the surrounding function signature. Can I just not? Like, can I just do this? Override. Syntax error. Oh, that's great. Yippee. Um, should turn that. Not like it does anything. This expression is type float string. Result was expected of type units. Yeah, but it was unit before. And then you just rejected it. What do you want from me? Can I like can I use that in assign in? Is that what I need to do or what? No. Yeah. So can I just do this? Why does it change its expectations? That's so weird. Um, Final results. How about we move this here, just for starters? Uh, yeah, still doesn't like it. Man, so what can I do then? Because like I just wanted to. I don't care what it returns. The alternative is to no. It takes this no. Like this should be fine. I want to take a list of tokens. I want to iterate through it. And I just want to have it work. It's like a for each loop. Okay, let me ask Claude. Because clearly I'm missing something fundamental here. Why? How can I avoid return type errors here with the list.iter expression? Burp, 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 burp. It's ruminating on it. The problem is that the list iter expression is called back to return units. You call back to the function results because of the let binding. Oh, it does expect units. I could have sworn my thing said, yeah, it's expecting a different type. I'm so confused, bro. The problem, okay, the clearance fix is placed on iter with a fold that threads the result through, bailing on the first error. A fold, you say? Let results equal list.fold left. Okay, that makes sense. Oh yeah, that's also true, I guess. Uh, where's the accumulator? Let's. Okay, why? Okay. So this doesn't return anything, does it? What if I just let like do this? Does that fix it? Syntax error on line 53, which doesn't exist. No, doesn't still doesn't work. Okay, so this says to use fold instead. List.fold left. So then I need to have the accumulator, which I think is on the left side. And I do I store it? I do. Because it folds the results, makes sense. So then I don't need this or this. When I unwrap the result, it's really weird. No tokens default. Well, an error, right? Although there should be tokens. Actually, yeah. What even happens if I just do if I run it and just give it empty input? Oh right, I can't run it. Final enter, I guess. Yep. Okay. So we'll have like an error. This shouldn't happen, to my knowledge, for now. And then what? It returns results, and I just return result here as well. Is that it? Is this in? Yeah. The expression is type units, but an expression was expected of type string. Why is it expecting line 41, is it? Because I need to return OK results. Tokens. The value tokens is type this. It wants an operator list. What? Seriously? So it infers this first. Can I just force it not to? Tokenizer dot token dot t. Oh no, it should be operator plus. That's fine. Fair play. Looks promising. This expression is type float of string results string results. What? So the whole expression is of type right because I said I need to unwrap the results. So like let final results equal results in, and then just do this. I mean, here it just ends it with an in. I assume that's not meant to do that, but like, is it telling me this just like as a placeholder? Also, why is the accumulator not? Yeah, why is the accumulator not actually accessed? Like at that point, why even unwrap it? Why bother? Good time to think. Um, okay, this should fix that error. Unused variable tokens. That's a warning, which is also an error. Warnings as errors. Let tokens equal begin match tokens. Probably because I need to here. I need to tokens prime. Okay, so if I just do empty, by the way, okay, I should probably fix that. Or like, well, I mean, it's not broken, but like, I should change the error message to be like, no input. So let's try this then. 5 plus 5 gets stuck. How about 5 minus 2? Unexpected end of expression. Okay. Good catch. Good catch. Be serious. Oh, that's right. Yeah. I need to. I just need to do this because it means that not there. Where is it here? By doing this, I am saying if the accumulator is an error, then return early. Basically, that's basically what that means. Um, okay. Why is it on an infinite? This shouldn't happen. It happened. 5 plus 5? Infinite. Yay. Oh, right, because it starts with this. Okay. 0? I don't know. I mean, an empty is fine, right? Yeah, so it's fine. So if I do 5 minus 2, plus 5 again, weird. Very, very weird. Um, unexpected end of expression. Where's that even coming from? How do I search? Find files. I forgot how I search within my files. It doesn't matter. Lexicon parser probably. And the error is unexpected end of expression. Okay. So it is the parser that's failing. Because I this should really be inside, shouldn't it? Yeah, it has to be. It has to be. So move this inside, or just delete it and paste it. And we put it like here. Okay. So here's our token pool here. And then we want to parse tokens here. And then here, we are actually just taking tokens like this. Okay. I mean, that fixes that logic. I don't know if that fixes this error though. I got a different error. Unbound constructor identifier on line 24. Unbound. Token pool. This returns just a list of lists. So token pool is matching on a list right now. Yes. A list of what? A list of tokens. So what? Unbound constructor identifier. Like it doesn't recognize it. Maybe the inference is too weak. So tokenizer dot token dot identifier. Like this. Yeah. Okay. That was the mistake there. The issue. So still, if I do 5 minus 2, it still gets unexpected, and if I do 5 plus 5, it's still infinite loops. So let me see if I can do this instead. So token pool, but we'll give it a type of tokenizer.token.t. First of all, is that even valid? No. There's no constructor within, sorry, list. Yep. This seems like it should work then. Which means I can remove these again. Whoops. Yep. Yeah, okay. So the type inference just kind of failed there. Fair enough. Okay. So why am I having issues then? Like it should be splitting on 5. But it says, but 5 plus 5 is becoming an infinite loop instead, which is not what it should be doing. split by delimiter. There is an end condition. Is it because I'm not removing the delimiter? How do I do this then? If the list starts with a delimiter, then I need to remove the delimiter. I mean, the easiest way I could think of this is just to uh, I mean, what I was going to say is just like do this, like just copy this and then add a thing before it to match for that. Uh, how about I do let list prime. How would I do it in Haskell? Because like I've done this before. Um, I've played these games before. Uh, let's have a look at what Claude said. It did do a go function. Accumulator equals empty list, then empty list. Otherwise, list.reverse accumulator. What? Okay, this isn't using take or drop while. What? I said I don't want more convenience. I literally gave it instructions that I don't care. Okay. Damn you. Um, what about with take while and drop while? Because I need a way to know. When pred x. What's pred? Okay. So is that just no, okay, what? Empty cased before rest after. Before split by pred after. Yeah, how do you drop the delimiter? I can't remember. Before let's just take while, not this. Rest, not this. After is you take rest. List dot drop while pred rest. Um, what? Would you not take while here? Or even take everything? Oh, drop while it is equal to delimiter. That makes sense. That makes sense. Okay. So yeah, and let's use let here to make it just cleaner. So we have we have our pool, our list, sublist, and then we have the rest, right? So we have our sublist, which is this, and we're going to return sublist cons onto split by same delimiter of the rest. Okay, so in here, let's what's it? So you have the sublist, then you have then we want to drop the delimiters. So skipped, let's say. No. No. No, because we need to get the rest of the thing, right? So I'll just do rest equals this. Or delete this, just this. And then rest prime is list.dropWhile x equals delimiter. That's right, of rest. This part is the same thing, right? Yeah, yeah. Prime. Okay, so that should parse it properly now. Or like split it properly, I should say. Which means I should be able to get 5 plus 5. Okay. It's not an infinite loop, so that's what I need. But we are getting unexpected end of expression um, for literally everything, which is annoying. How is everything? Okay, so I definitely need to view the output here. So 5 plus 5, what's happening? Tokenizer is giving us a syntax tree of 5 and 5. Oh, so it's just results that's wrong. Probably because it's trying to do it again on an empty list. Is that what? Okay, that must be what's happening. Like here, I'll just print and line beep, so I know how many times it goes. 5 plus 5, beep, beep, beep. Yeah, it beeps 3 times. So it's going a third time for some reason. If I just do 5, it goes twice. Why is it doing that? Um, Otherwise, it actually works, which is cool. Um, Fold left. Can I print my list? Surely I can. I think I can. So how do I do this then? Um, I can do it here actually. No, I can't do it here. How do I do it? Um, like here. If I take this, okay, probably a good idea anyway to just take it. So take that. We'll call this our pools, token pools, plural. Say let token pools equal this in, and we're going to print end line our token pools. So show token pools. No. Okay, in brackets. Show tokenizer.token.t list token pools. Do I even need to specify this type, by the way? Because like it should be able to infer it, but whatever. It's an external library, so I don't know. Okay, that worked. Let me just remove the verbose, whatever. So if I do 5 plus 5, yeah, as I thought, there's just a random empty list. I can only assume it's because I did this. I thought that felt a bit fishy. In fact, if I just look at this, yeah, literally. Also, what the hell? LST prime. I don't even use this. Because it calls the entire function. Yeah, what? This why is it even named? Okay, let me just do this. So 5 plus 5, 5. Because I mean it's big on 5. So if I do like 2 times 3 plus 5 minus 2, I should get 3. Yes, because it's doing the left side, discarding it, and doing the right side. All right, this actually worked, much to my surprise. So let's go ahead and use a proper delimiter. We want to not print this, but we want to operator. Is it even operator? What what do we call it? What's the word? A separator? I'll just use semicolon for now. Um, but this let's put an official name for this. What is the official term for a statement ending in programming? Uh, yeah, I can't think. I can't remember. Statement terminator. Who would have thought? Or separator. Let's call it a terminator then. Or a separator. Yeah, I'll call it separator. How do you spell separator? Separator. Native English speaker, by the way. Okay, that'd be fine. So I just need to copy this. Do I even need this? Like, does it know it? Can it infer that it's can it infer that it's a separator? Well, I mean, I don't know yet. I need to first make sure it compiles. So let's go tokenizer. We're gonna add. How did I get here? It's actually cooked. Okay, what the hell? Um, that's just completely interrupted my train of thought. Yeah, separator. Okay, so semicolon is a separator. I'll add that like here. Token map. Yeah. Y boom. Token dot separator. Why do I even need to specify the type there? I do not understand type inference. It seems a bit inconsistent to me. Anyway, this should work. So now I can do x store 5, y store 3, x plus y 8. There we go, chat. We did it. And if I do something like 5 plus 3, followed by 8 times 2, the left side is disregarded, much like the comma operator in C. Awesome. Awesome, awesome. And I can use X still outside and Y still outside. The scope is global. It's literally just chaining operations. Now, I could change this. What if it was like this instead? I was thinking I could use a triple equal sign, a triple thing sign. I feel like that'd be kind of fun, especially because this already uses it. Yeah, you know what? I'm gonna do that. It's my language, damn it. So we're gonna do. I'm gonna do this instead. By the way, how do I even like? I can't use a string list rule here, can I? So I kind of have to go like this. But I don't know. I don't like this. Whatever. It is what it is. So look at that. So again, x5, y store 3, and then let's do x times y, 15. Awesome! Awesome! I wonder if I can... That's fine. Likewise, x plus y can do pi times x. Yo, e times y. It's all there. It's all there, baby. Okay. I definitely... Oh, yeah. So, I mean, okay, so that's another thing I can scratch off the list, which is this. These two are now done. So let me commit this, git add, git commit. Oh, actually, let me update my tests as well. Eval test. Okay. Just do the same example I did before. So boom, boom, boom. That should be 15. Nice. So yep, git add, git commit, add chaining, add statement chaining, like inline, and then git push. Okay. And I wanted to fix something because if I do this with an empty, I get 0, which isn't what I want. I want it to output an error. Now the issue is, I think the 0 is coming from here. Okay, 0. There should be an error. But the thing is, if it's an error, then this whole thing is going to also error. Unless I just don't unwrap this. Like I could just ignore this. But then like if there's a parser error, so it's gonna get ignored. And that's not good. Like if I were to run this and have 5 plus and then just 3, I get an error. It doesn't tell me where the error is though, but like the point is I get one, whereas I wouldn't get one otherwise. Like if I had like 4 plus x 3 and I like try to print x. Okay, I think we have bigger fish to fry, or like 2. Okay, well if I define, because it's left to right, if I define x first and then try to do this again, yeah, error cannot parse tokens, and it would tell me the tokens. Show. I can't really remove that. So how do I have an error case? Like a default error case. Oh wait, what am I saying? I can just check. So if where do I do it then? Here. If token pools equals empty list, then error, no input. Else do literally everything else, right? It's a bit sneaky because I can't like write early return. Yeah, no input. So 5 plus 3. If I do like this, do I get no input? No. Makes sense. Or this, no input. Cool. Nice. I like this. So git add again. I'm going to commit report empty input rather than defaulting to 0. Push. Push. Okay. And there was something else as well that was bothering me. What was it? I can't remember. I can't remember. Screw it. It doesn't matter. Right. 2 features. An hour has passed. Pretty good. So now Functions. Let's get functional. Let's get functional. So I'll start by just adding not user-defined functions, built-in functions, and then I'll do user-defined later, because that's gonna be harder. So, okay. So our goal, because you always start with the tests, our goal is to have a function. Some example functions we could have, obviously sine and cosine, and log, but like if I did cosine of pi over 2, I don't know if it'll give me that. Anyway, can I get OCaml online? I can. What in the world? Okay. Hello? Go figure. Let x equals 5. Okay. Print end line. Hello? Okay. So if I do 3 plus 3, nice. Float dot cos. And the expression was expression of type float. Oh yeah, I did. So float, okay, nice. So if I do float dot cos of 3.141592 6 5 3 5 8 9 7 9 3 2, I think that's how long it was, and divide by 2, gives me 6.1. It gives me a very small number that's close to 0 but isn't 0, which is problematic. Now I wonder if that's because it's checking it itself. So is there float.pi? There is. 3.1.19265358979 323. Huh? 3.1 Okay, well now I've just forgotten. So if I give it the perfect number, float.cos, and give it float.pi, -1. Nice. And how about over 2? Nah, it's still very small, but not perfect. Because the thing is, I want cosine to give me, like, cosine of pi over 2 should give me, uh, 0, right? Because floats dot cosine of 0 is 1. Um, yeah. Okay, well, I'll tell you what then. I'll just do eval test okay. Cosine of 0 should give you 1. That I can at least easily write. And then sine of 0 is 0. I'll do abs as well. Why not? Absolute value of -5 is +5. Tangent is just sine over cosine. Can add that later. Logarithm, I'll also add later. Okay, I mean for now these only have one argument though. But let's start there. Also these will be in degrees or radians. I assume it's in radians by default. Like if I obviously if I do 90 degrees, I do not get what I think I would get. But if I do okay. Okay. So I could convert it to degrees actually. I mean I kind of want to write my own custom implementation of sine and cosine. So I might do that. So let's do let's do abs first, just because I know that I can actually implement that. So tokenizer, it's time for functions. Yeah, so C's when it's constant, C's when it's an identifier. So for the built-in functions, they will be constants. So I need to actually make these capital because these cannot be reassigned or anything. They are reserved. So tokenizer, go back. Okay, so I need to check if remaining contains. Well, if the first letter of yeah, if the first thing in remaining is a function thing. No, I take it back. I take it back. Okay, so here's the issue. I substitute constants in the tokenizing stage because I didn't really think that this would happen or like that'd be a problem. But I'm realizing I really need to check if there's a function in the parsing stage, which means I can't substitute the constants at this stage. So let's see what I can do about this. So the parser, well, no, because it puts in a number. So I need to actually identifier, keywords, identifier. I'll call this user identifier, and this will be reserved or like app identifier. Because like I can at least make that distinction in the tokenizing stage, but I can't do anything else. So app identifier, user identifier. So now I just need to change this to user identifier. And instead of doing this, we're going to do the much simpler, just token map, token dot app identifier of constant remaining. Okay, then this logic is moved to the parser. So, I mean, it'll be up there with identifier, obviously. So this will be user identifier. And then let's paste this here, copy this, app identifier. Okay. Yep. So if hash table mem, then token map, otherwise undefined constant. So that just initially should work. My test is going to fail, isn't it? Doesn't matter yet. Unbound value constant, because this should be ID. Still. Whoops, there's more. Token map, unbound value token map. Yeah, what? I can't do this. I need to do something else. I need to return a number, right? So just okay. Okay, number this, and then tokens. Yeah. Yeah. 29. What's wrong? Calculator.ml. Huh? Oh, right, because I am checking this. Um, yeah, sorry. So this is 29. This should be user identifier. If it is, then substitute it from the list. Yep, makes sense. Why do I do it here? Oh, because it's for definition specifically. Yeah. Undefined constant abs. Okay. As I thought. My question is just that can I use this normally first? So still pi times 3. Looks good. Okay. Good. So now for the functions. Now for the functions. So we're looking in, again, the parser still. I could technically save this, but I feel like I might as well substitute it here. But anyway, I need to use the output identifier to check if it's followed by a function. And the way I do this is by having this as a special case. So we want an app identifier ID, and then we want a check if there's a parentheses open. Thanks. Okay. Onto tokens. Okay. So this will override this, which is good because then just makes it easier. And yeah. So then we need to parse the args. So I think we run this, don't we? Yeah, we want just what's inside the tokens, inside the parentheses. I mean, also I could like take a while, but I feel like I can just use this logic here because this logic just, oops. Um, okay, let me just copy paste it and see what happens. So expression, rest, parse all these are tokens, and then rather than returning this, we want to keep this. So and we don't care about the rest. So we do want to check if there's an error. Rest should start with a closing parentheses. Yeah. I think we do want this actually. Okay, sorry. So we want both because we need to then return the rest. But at least initially in this branch here, we want to take expression and call a function with it. Like use those as our arguments. So we're going to say, yeah. So let's do it like this. So let args equals expression. Or rather, just name it here args. Okay. And we want to let's just return for now just to test it. Let's do 5. and then the rest. Okay, this should work, I think. This is type int to list string, but it says there's of type parse results. The expression is type int. Yeah, what the hell? I'm returning int. So I'll just return number 5. Will type reference even work there? Nope. Expression dot number should work. Boom, boom, boom. The constant 5 was type int. I did mean this, yes. Uh, yeah, do I like this, by the way? Like the way that it forces you to suffix floats with this, um, as if you had like to do this, right? It's do I like it? I don't know. I don't know. Okay, so can I do cosine of whatever? 5. Cosine of 3. Let's say that was 5 plus 2. 7. Nice. That's it. We've done it. And then obviously if I have any syntax errors here, that should propagate. Yeah. I mean, the errors aren't that helpful in this case. I don't know if I will try to improve the error messages, but definitely it is working. Nice. So, I mean, this will now work, right? If I do abs negative 5, it give me 5. So my tests should ironically, for God's sake, how's it even compiling? Okay, it just knows. Yeah, so my test will actually will pass, but it shouldn't. So we have our args, and now I need to evaluate this. So the first thing I should be doing is checking a hash table of functions. So I'm going to actually, I'll see if I can reuse my current one, hash table. Uh, hmm. Like, can I make the key be a function? No, not the key of the value. No, I can't. So I'll make a new thing called let functions, but they'll be these will be the built-in functions. So built-in functions. It'll be a hash table of string, and then they all return floats. Do they all take in floats though? I guess they have to for now. So it'll be a string, and it will return a float to float. Hash table dot to. So hash table dot create. We'll do 1 for now, which will be absolute value. List dot iter function key value. Hash table dot replace tkv. What's inside? So abs, absolute value, will give a function x, which will give me if x is less than 0, then negative, then x, well, then negative x. Should be fine here actually. Else x. Yep. So that works, I assume. So get back to the parser. Well, let's see if it compiles. No. Value x is type floats. Right. I can't do negative x like that. I have to do negative dot x, which is fine. Looks to compile. So now I just call the function. Pretty simple, if not a bit verbose. So I need to get the function. And it's a chance to error. So I have the identifier. So before I even parse the args, I'll do this. Thing is, if it's not a function, then what it should do is treat it as a user identifier. Because what? Yeah, because I want to allow both cosine of 5, right? And like x times 5. Like it looks like a function, but it's not. Um, like 5 times 3, like that kind of thing. Like this should be x times x. And I can do that, I think. So first of all, constants dot built-in what? Built-in functions, yep. With ID. Then we say okay, get it, please. Yep. And apply it. Apply it to what? Apply it to the args. Now the args is what? The args is an expression. So I need to evaluate it. Houston, we have a problem. I can't evaluate it yet because I don't know what the expression will be. Okay, never mind then. Ooh, that's not good. So we actually need to return. Okay, so we a new type. Number variable function of t. So the function contains an expression that's meant to be evaluated. Later, we'll need to make later I'll need to make this a list of t because there can be multiple arguments. But for now, there's only one argument. So beep beep beep. I may need to also differentiate from user defined and non-user defined. Okay, I'll call it built-in function. Like same thing really, it's just like keeping track of whether it is or isn't built in, because they both will access different tables. That being said, no, it has to do, because I don't want to allow assignment to non-ones. Okay, you know what, for now on, I'm not even implementing function defining yet, so let's just keep it simple and just do function for now. And then here I'm returning not a number, but a function from this list. Wrong thing. Here. Expression.function. What is the function, you ask? Well, it contains args. Yeah. I need to keep the ID, don't I? Yeah, okay, so ID as well. Pass the ID through. Um, Looks good to me. So string and t. Which I think means I need to make this a tuple. Yeah. Let's see what happens. Evaluator. Partial match is not, yeah. So that's good. So go to evaluator. Finally. And we have a new thing to handle. I'll put it here, I guess. So if we have a function with an ID and args, then we can execute, right? Yes, finally. So we say, okay, give me. So what are we returning? Float or error? Yeah, so like it is a float. So we're going to access our hash table. So hash table dot. Okay, at this point, we know it exists. So we'll do find in constants dot built-in functions. What the hell? ID apply to args, or apply it to evaluate args. Okay. So this is one big expression. We'll just split it up actually. So that function equal equal this part of things. Let args, let's evargs, evaluate args, just evaluate args. Yeah, delete all this. Okay. So return function on evargs. Yep. In. That should work. And now I just need to go to the parser again and actually add this check for whether or not it's a member. Show this needs to go here now. Okay. Yeah, so if the hash table dot, so if our constants dot built-in functions, if it exists, then we do this. If it doesn't exist, then we have to return an error, which is function not defined ID or undefined function ID. Yep. That's it, I think. Let's see. Oops. As evaluator. Yeah, this would be a tuple. Weird, because like Haskell doesn't require you to use a tuple for these, but this does. That looks right. Wait. Yeah, it looks good. Evargs has high flutter error. Oh shit, it does. That's right. So I need to actually do this. Lippy. Lippy. Yippee. Okay. So now if I do abs of -5, I get 5. Abs of -3. Let's go. Yeah, that's invalid. Let's go. So I can do abs of 9 times -5 plus 3. That's not plus. 48. Awesome. Functions. They're done. I'm done. I'm done. Okay, so some checking. I can do this. I can separate the thing, which is fine. I don't mind that, I guess. You can do abs of 5. That doesn't work. You can do abs by itself. Doesn't work because it's treated as a constant as well. Abs with empty brackets doesn't work because it has no arguments. Abs of, well, obviously multiple won't work either because we have no things. Let me actually see if I can add a bit of a useful error message here in the parser. If args is empty. So that's this, right? Dun, 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 dun. I guess the unexpected token error, don't I? It's a bit strange. Why do I get that? Because it's empty. Yeah, it's an empty list. So, oops. So I guess I can do like if args equals empty list, then error, no arguments provided to function ID. Else. It's kind of going off the page there, but yeah. If args equals empty list. Args is an empty list, no? I mean, args is a list, no? Um, it's expecting type expression T. There is no constructor. Oh, it's an expression. So I need to check if it's an empty expression. How do I do that? Low key, how do I do that? Um, just immediately error. So why? No, so this is wrong. Instead, what I can do, is say if tokens, if tokens dot head, no, list dot head of tokens is parentheses tokenizer dot token dot parentheses close. Yeah. Let's see. Did you mean list? I did. Okay. So if I do abs empty, perfect. If I do 2, fine. Fatal error. Yeah, that's the only downside. Headphones an exception. Um, that's annoying. That is annoying, actually. Screw it then. Screw it. Unless I can think of a different way to do it. If I could check like down here, I could do it. And I mean, I could do it like by storing like a variable and like checking like that's like a boolean, but like storing like previous token and then like if it's a whatever. Yeah. I can see it. I can see a good system for doing it, but I don't want to set. I don't want to set up that system for this. I'll do that. I'll do that in Rust. Show cool. In that case of mind, it works. Anyway, like the actual functions work, even if I don't get the error messages. Squeaky perfect. Let's just try again. Make sure I didn't mess it up. Yeah. An empty brackets will be that, and this will just be a normal error. Okay. So now I need to add some more variables, functions. So let's go to test calc and comment these back in. And I guess I'll add some more cases here. Sine of 0 is 0. Sine of pi. Thing is, how do I check pi? I can't really, can I? Whatever. Yeah, how is sine actually implemented? How is sine implemented? Taylor series. Oh boy. I actually don't know if I want to do that. OCaml? Can I see OCaml's Haskell sign? I want to see the implementation. Sine of pi over 2 is 1. Good to know. That means it's actually like a proper sign. Implementation. Haskell source. GHC. How do I even navigate this though? That's too much. GHC. GCI. No, surely not. What's it even coded in actually? Like surely it's not coded in Haskell. Oh my god, it actually is. It does use some C though, but like actually not that much. I mean, 8% is actually quite a bit, but like, goddamn. Pipeline failed. That's great. We love to see that. On April 24th, we start using GitHub Copilot integration data AI. I don't care, to be honest. Um, libraries, math, maybe. Template Haskell. I heard template Haskell is really hard, although I haven't like looked into it. Is there anything with math here? Compact boot internal platform. I probably in the wrong folder. Those are like GHC extensions. I need the actual compiler. Language Haskell, yes please. Syntax, yes please. What's it say? Yo, is this literally the tokens? I don't know. Syntax, basic to HS. Damn, I'm learning just by looking. Um, module? No. Decals, expression. God damn. Okay, I need like specific libraries. Okay, here we go. So I think it's in. Well, I think it said, didn't it? Not that. Um, Haskell sign. I think it's in Prelude. Yeah, it's in Prelude. Okay, so let's find Prelude. There it is. Basically HS. What do you mean basically HS? Where's the bloody? Where's everything else? Does it include other things? That is the module. Import foldable list types. Import prelude. Oh. I don't see where the maths would lie. I want to see the implementation. Please. Open source for what, bro? So hard to find. Okay, I know it's in prelude, but where? Um, okay. Built in, no. Core? No. Data? The data library? Okay, that's there. So where's the maths module? I mean, it says it's in prelude, but I don't see anything in prelude. Unless it's literally okay, it's prelude to HS. But that's nothing either. Import basic. Okay, that's not really what I want. Oh man, okay, you know what? Let's ask Claude. Can you point me to Haskell's source code for sine? Like, what does this? Why is it not here? Is it missing something or mirrored? Is it missing anything? Last commit 2 months ago. Damn, 2 weeks ago. Sorry, 2 days ago. Haskell team is slacking, bro. Slacking. Point tab. Sign in Haskell bottoms out as at a compiler primitive, not a pure Haskell implementation. Okay, that would explain why I can't find it then. Sign x equals sign double. Okay then. So it's C sign. How does C do it? C GCC source code. libcc? No. libgcc? Okay, can you point me to the GCC source code then for C, C++? I gotta see how it's done, man. I mean, it's probably Taylor series, but I digress, man. Let me see it with my own eyes. Sign in C is not part of GCC. Sign lives in glibc. Fair play. It doesn't use the C code hand tune assembly. I'm going to shoot myself. Okay, well, show me this instead then. I'm not a bot, don't worry. Or am I? Okay. Um, God forbid it's easy to read. Yep, it is indeed Taylor series. Okay. Since this is Taylor series, I'm just gonna use. Okay, can we not do that? I'll just do this. So sign, I'll just define as math float dot sign, and then cosine for here. Yeah, that should work. Let's get it. Come on. Make up my G. Cosine of 0 is 1. Sine of 1 is 0. Sine of 0 is 0. Sine of 3.141592653558979323. Yeah, it is 323. Fucking liars, man. 32384626433. Well, it is definitely close to 0. How about just 3.14? How about just pi? How about, yeah, like it never goes to 0 properly, which is annoying. But okay, that's fine. So let me June test. I mean, I could override it. Nice. How would I override it though? I'll just say that if it's pi, then trim it. This is Python's value, by the way. This is different from what this thing uses. So allow me to actually just replace this with float. I mean, if I'm going to use sine and cosine there, then I should use float dot pi for this, just for consistency's sake. I mean, I kind of have to. So now let's try sine of pi. Still the same, but we can override it. So we can say sine is a function of x, where if I mean, we could match x to be fair. Yeah, screw it. Function if it's pi, so float.pi, then it's going to be so sine of pi, by the way. What is sine of pi? 0. Sine of pi is 0. Sine of pi over 2 is 1. Right? Yep. Sine of 0 is 0. But that's fine. Obviously it's different for like 2 pi and whatnot, but that's okay. Actually, no, okay, well, I need to add negative float.pi as well. Or negative dot float.pi because it's a float. That will give me -1, and by this I mean over 2. Yep. Yep. Holy moly, this is just terrible. -1. Base case, just float.sign. No, base case x, float.sign of x. There we go. I knew something was weird. There's no semicolon there. I lied. Kinda, not really. Like this. And same for 2 times float.pi, because someone might do that. Beyond that, I don't care. And yeah, let's see how this compiles then. Syntax error. Does not fall through. What's wrong? What's up, danger? What? Syntax error 916. I mean, it's just function of x. We're doing match x. What in the world? Why is this a syntax error? I've literally done like thousands of lines of pattern matching at this point. Why is that an error? Yeah, I'm just checking the float value. What? Is it the type? I mean, if it is a type, it's not telling me it's a type error. It's an x to an x. Hold on, this should return this first of all. Um, does that fix it maybe? How is it a syntax error? How is it a syntax error? Float.py. Am I? Huh. What? Kojo just killed itself. Pi is a value, not a constructor. I can't pattern match. You can't pattern match values in OCaml? Are we dead ass? Are we dead ass? Oh, what? Okay. Is float.py not a x when x? Yo, this is like C++ is on track to make better pattern matching than OCaml. Hold on. Shout out C++, by the way. They are doing some cool stuff over there. Okay, fine. I'll just have to do this for each one then. Okay. Maybe it should work now at least. Because I'm doing 2 times. Yeah. Put a dot literally bloody everywhere. How can it infer like enum types, but it can't infer that my thing's a float, man? The constant 2 is type float, because I'm doing a times. I have to do times dot. Look, I get it's type safe, but it's quite annoying. Okay. Anyway, this works. So let's do sine of 0, sine of pi, sine of 2 times pi. Let's break it. Sine of 4 times pi. Oh, okay, but sine of pi over 2. 1, like to see it. Sine of 3 times pi over 2. -1. Lovely. Um, how even? Negative pi over 2. Okay, that just works. So what I can actually do here is instead do match. So function x match x with, and then Instead of x, I'm going to match, sorry, it's just the n. Is there modulo? What's the OCaml float modulo? Mathematical modulo? And not the C one. Mod float for floats, but there is a remainder, so it can be negative. Flippity flack, man. Well, I'll tell you what, I need to add a modulo function anyway. Show. Let's mods, maths mod. Yep. AB, XY as I prefer it, equals, let remainder equal with mod float, so x and y in, and then what do I do then? If r is less than 0, then r plus b, else r. Okay. If r is less than 0, then r plus b, else r. Sure. Sure. Okay. Likewise, I'll define these as well. Let's sign x of y, x and y, x. Oh, I can't do mod yet, can I? Because that's two arguments. But whatever, it's there. Do it later. Sine of x equals match n with, no, I got to x, equals match x with, then just copy this shit, right? And change all of these x's to n's, and then maths mod, so x 2 pi. So it actually it wraps around. Okay, and then just replace this with sine. Okay. Unbound value b, because mine's y. Yep. Fraud. Oh my god, this again. 2 times float. So this should wrap to 0, so this should be 0 anyway. So that's fine, I don't need that. Okay. So sine of 0 is 0, sine of pi is 0, sine of 2 times pi is 0. Likewise, if I go any higher, it'll be the fine, same. Pi over 2, give you 1, hopefully. Sine of pi, or like 5 times pi over 2 even, should still be 1. Likewise, if I go negative pi over 2, negative 1, negative 3 times pi over 2, that's 1. But if it's negative 5, should be negative 1. Likewise, if I have positive 3, negative 1. Nice. Perfect. So now I can apply the exact same logic to cosine. Let me just pretty this up real quick. It's just a bit easier to read. Okay. It's still kind of hard to read anyway, but whatever. Cosine, same thing, just kind of flip the values here. So cosine of, oh, I was only 0, don't I? No, I don't, that's fine. So cosine of 0 is 1. Cosine of pi, so what does it say right now? If I do June, Cosine of 0, what was it? 1. Okay, so cosine of pi is also 1. Cosine of pi over 2 is 0. Cosine of negative, wait, I can't remember now. I can't remember, and I can't be asked to visualize the graph. So cosine of pi is negative 1. I thought so. Cosine of 2 pi is positive 1. That's right. So cosine of 0, because yeah, that's 1, that's fine. Just make this negative. Don't think I even did the brackets here, do I? But negative pi over 2. How's it even evaluating this? This should be 3 pi over 2, really. 3 times pi over 2. Likewise. Yep. So yeah, cosine of pi over 2 should be 0. Pi over 2. Mind you, I could just define this as sine of, actually like sine plus 2 pi, right? Because like sine of 0 is 0. I think cosine can just be defined as sine of whatever plus, okay, so let me remove this. That's right, we're changing it now. And we'll do just sine of x plus float.pi over 2. Should be the same, if I recall correctly. And actually, I'm gonna do a test for this, like in my tests, as I should. So yeah, so we can now confirm sine of pi should give us 1. Sine of 2 times pi should also give 0. Sine of 3 times pi over 2 should give negative 1. And pi over 2 itself, sorry, pi should give you 0. Oh, yeah. Pi over 2 gives you 1. This gives you negative 1. And then we'll do negative as well. Negative pi over 2, negative 1. Okay, and then cosine is just the same, but in reverse, pretty much. Not in reverse, but you know what I mean. So replace all of these with cosine. Yeah. So cosine of 0 is 1. Cosine of pi is 1. Is it? Or is it negative 1? Negative 1. Cosine of 2 times pi, same thing, just 1. Cosine of pi over 2 is 0. And then therefore anything else like that is going to be 0. Yeah. For negative pi, it would be negative pi would be positive 1 as well, I think. Cosine of negative pi, negative 1. Why? Pi is 180 degrees. Oh, yeah, of course. Yeah, that's fine. Okay, cool. Let's just test it. Okay. Dot, oops, dot, try again. Still. I love floats. I just love doing math and programming. It's so fun. All the tests pass. So there you go. I've implemented sine and cosine. Beep beep. So I can do git add, git commit, implement built-in functions, including abs, sine, and cosine. Okay, let's edit the README at this point. So those are the operators, variables, constants, built-in functions. Functions, there are built-in functions provided, and like the constants, they all start with an uppercase letter. They are called like you would expect in maths with parentheses notation, i.e., e.g., sine of pi. The existing functions so far are abs, I want to get the arrow, but it won't let me type it. That's annoying. Absolute value, sine, trigonometric, sine, cosine, trigonometric, cosine. Sine is specially defined such that the intervals of pi over 2 give exact values between 0, 1, and -1. Cosine is simply defined as sine of x plus pi over 2, so the same is true for it. Okay. I've added more operators, haven't I? So we got equals, greater than, A more than B, lesser than, lesser. I don't like that. Less than, greater or equal to, less than or equal to. Okay, I can remove that from my TBA. Changes to user defined functions, as well as more built in, such as log. E.g. log mod exp chaining commands. All numbers are treated as floats, although there is no supported nan or infinities. Sequences, expressions can be chained in one line via the operator, and functions as if you wrote the same stuff on separate lines. So just I'll do it in the real thing so I don't make a mistake. So again, x5, y3, x times y. I'm a fool. Yep. Yeah. Except only the final expression, only the result of the final expression is printed. Actually, what's it like in debug mode? Because I feel like it's probably not so good. Like if I do 5 plus 3 and then 2 plus 2, wrong way, I get 2 trees. Honestly, that's fine though. I don't mind that. Okay. Uh, done. Right? Cool. So can I commit this again? I said very simple. I don't know if it is. This is a command line calculator like Alex expressions programmed in OCaml. Mathematical expressions. Sorry. Yeah, so git commit, update docs, git push. Awesome, 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 awesome. Yeah, look at all those operators. Look at all those operators. God damn. I'm making a table at this point. Yeah. So I could add log base E, and I could also add x, exp, like those are also one argument functions. But okay, so done for that, right? Other features then, so more constants. Again, those are easy. I could do that right now. I just can't be bothered. User-defined functions as well as more built-in, like log, mod, and xp. Um, for multiple argument functions, I would need to kind of use the same thing I did with the separation, the expression separation operator, except make it a comma. I wonder if I can abstract that into its own reusable component then. Maybe. Think about it. Uh, then implicit multiplication for numbers next to variables, um, like this. It can be done. I don't think there are any drawbacks, right? It's just that it only work with with numbers before variables, or variables before parentheses. But I don't want to do I don't want x5 to be valid because what if your variable is called x5, and I don't want like xy to be valid because xy could also just be a variable name, right? Um, Obviously, it'd be different if I only allowed single letter variable names. Then I could do it, but I'm not going to do that. Yeah, I'm not going to do that. Um, is that it then? 5x and yeah. So it for a number, it can be before any expression, I think. And then for variables, they can be before any parenthesized expression, but they cannot be before numbers. That being said, like I guess I could technically allow um I could allow like x5 or like xy for x times y, but I don't know, I don't like it. Like 5xy plus 2x plus 3y as opposed to 5 times 5xy. Hmm, I don't know. I mean, the main thing, honestly, is just being able to do um 5x squared plus 3x plus 2. That's what I want. Because right now you have to do this. Obviously x is undefined, but yeah. God, I'm so confused right now. No, no. Ah! Okay. I actually wanted to add something else, which was the ability to quit. I've just remembered. So if I go back to my main, all the way back in the main, have not been here for a while. If the input happens to be yeah, so if input equals what should quit be? Q? No, because no, colon Q. Yeah. Then quit. Else everything else. So let's try running something. 3 plus 4, colon Q, colon Q, colon Q. Okay, it's still recursive. Um, Interesting. If input equals colon Q, then this. Why doesn't that just end it early? Is it because of this? Yeah. Else begin and that should work. 3 plus 3, colon Q, exit. Let's go. So very simple, very easy there. Git add, git commit, add ability to exit program gracefully, I guess. Push. Before that, readme. To quit, just enter colon Q. There you go. Now you can quit. In fact, I'll even add it to this. Not KKK, don't do that. Git add. Did I save it? Um, add :q to example. Yep. Nice. Nice. So that's pretty much it. A command line calculator is on OCaml. Okay, how long has that been? 2 hours and a half. 97% OCaml now. What? Let's go. Um, yep. So do I want to keep going here? I think I do. I want to knock this out. Let's at least allow numbers next to variables first, because that's the easier one to do. So back to the tokenizer. We need to allow it. Allow it, bro. Allow it, fam. In fact, right now, uh, what happens if I do CLS and run? If I run, is 5x, is it a syntax error or is it a parse error? Parse error. It knows that the identifier is x, which is cool. So I actually don't need to do anything to my tokenizer. It's on the parser. So with the parser, number n tokens. If it's a number, well, the thing is, the number can go before any expression. So how do I allow it? If token is an expression, can I do that? I don't think I can do that, can I? No. Okay, so let's make it a special case. If we have number n before an identifier, yeah, I guess. I mean, I have to do it for each one. It's a parse error, so I can't save it for the evaluator. Okay, so we'll do n. Wait, how do I do this? Hold on. I can't even. Can I even parse it? Yeah, I'd save it as a binary op. Um, multiplication. So number n multiplication and app identifier ID, I guess. But this could change it. I don't have to do this. I don't have to do this. Um, I guess the way I would need to do it is to treat the number as a prefix operator akin to minus, wherever a negative has gone. It's here, isn't it? Yeah. Like, see how I have this? The thing is, it can be by itself. So, like a minus has to be before something. If you have it by itself, then it's a parsing error. So if I were to try doing that, okay, if I were to try doing that, I'd have the same issue, no? Maybe not. Hmm. Maybe not actually. Nah, because if you've like 5 minus x, that could be parsed as 5 times negative x. So I need the minus operator to have lower precedence, which would mean a new layer. Mm, okay, you know what? Yeah, I'm gonna leave it. It's a cool idea, but not so simple to implement. I need to split it up, and I don't want to do that. Okay. Um, cool. So, any constants I should add? Like in physics, you have. I mean, there's so many though. Like I don't know. There are too many. Like I could add an arbitrary amount. Like I could add gravity, I guess. Like 9.81, but like why? Yeah, whatever. And then like mod and log. Eh, mod needs 2 arguments. So I still have to figure that out. Log would take 2 arguments as well, but I can have like log base e or log base 10, log base 2 defined, and then exp. Yeah, whatever. Honestly, I think I'm satisfied. I think I'm quite satisfied with his calculator. I'm just gonna go ahead and make a new release for all my awaiting users. Uh, New tag 1.3.0. So functions and chaining. The functions the single argument functions abs, sine, and cosine have all been added. Have been added alongside alongside a bunch of ordering Boolean operators. Also it is now possible to chain expressions via the operator, like semicolon. Like semicolon chaining in, yeah, whatever. Uh, like C's comma operator. Yeah, because everyone knows that. Um, yeah, can't remember what else I did. But doesn't really matter, to be honest. Programming projects. Boom, 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 boom. Babushka. Nice. Cool. Cool, 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 cool. Oh, yeah. I had a thought there. What was it? I had a thought. I don't know what it was. But anyway, there we go. 2.5 hours. So I've worked for like over 5 hours on this project today. Whoa! But yeah, I feel like I've reached a point of satisfaction where I want to move away from OCaml now and go full in on Rust. Because with Rust, I can do the tedious things, but I know at least that it's more worth it because it'll be a more long-term investment. The question is, for Rust, would I be doing a calculator or would I go ahead and implement a whole programming language? Now, to implement a programming language, I already have variables, right? Variable assignment in my calculator. Um, I was already thinking like it would not be too hard to add a ternary operator for if then, but even like if then statements could be added, and those probably wouldn't be too crazy difficult either. And like, how much do you need for a language to be Turing complete? Like, a calculator itself is probably Turing complete, isn't it? It can't loop, I guess. That's the thing. Um, yeah, actually, how do I do recursion? If I were to let people define their own user functions, I don't know. Um, yeah, that would be that would be a whole can of worms. But I will think about it. But yeah, I mean, you really don't need much. I mean, the bigger question is, if I do make a programming language, what will it be? Because I do have ideas in isolation for things to put inside a programming language. But as for like what language I want to make specifically, like what domain, what yeah, what domain? I can make it like a systems programming language, like C++ plus plus or C, but obviously that's that's quite complex. Um, then again, is it complex? I can also like, do I compile or like do I use the LLVM, MIR, or do I transpile, or do I skip that and do the entire, the entire stack by myself, including optimizations and to assembly? Surely not. Oh, I could. Um, I could even make an assembly clone, not clone, an assembly, a macro assembler is what they're called. Although I don't know if I care to. Uh, but yeah. Also, yeah, type system. Holy moly, type system. Obviously, in this for this project, everything's been floats. If I were to actually have a type system, ooh, I don't know. I don't know how that would be. So, oh, and actually, if I do my own language, I will be because like so for this calculator project, I've been doing everything just kind of blind, save for the initial steps for because I had my Haskell project ready. But everything else in the past like 3 videos has been blind, more or less. Um, but if I am going to move to Rust, I will be reading. Uh, I'll be reading. Where is it? I can't find it, but it's the book for crafting interpreters. And I want to read that book because that will teach me how to make an interpreter and a compiler. Hopefully with type systems and all that. So yeah, I'll see what I do then. Stay tuned for more. Subscribe to see that subscribe to see that happen.